My name is Karina Curl, and I'll be your moderator for today's webinar on a deeper dive in accelerated innovation, engineering smart products. If you have any questions throughout the webinar, please type them in the questions panel as they come up. We will have representatives ready to answer your questions directly during the webinar. Today, our webinar is presented by EMA Design Automation and Dassault Systems. EMA Design Automation is a leader in product development solutions offering a complete range of electrical and mechanical CAD tools, plus much more. EMA is a Cadence channel partner serving all of North America. Dassault Systems provides businesses and people with a virtual universe to imagine sustainable innovations. With world-leading solutions, the way products are designed, produced, and supported are transformed, which we will get a glimpse at during this webinar. With that being said, I want to thank you all for joining us for today's webinar and introduce you to our presenters, Ed Clark and Lou Feinstein. Ed Clark is a business development director with EMA. Ed started his career off as a weapons and space system designer. He has since worked on many NASA, government, and military client programs around the world. Ed was with Cadence Design Systems for almost 20 years and has had global management positions for PCB design, signal integrity, and IC packaging collaboration with IC design software groups worldwide. Lou is an experienced executive and visionary engineer with diverse hands-on experience with organizational development, product and project management within varying size softwares and product organizations. He is skilled in identifying and cultivating strategic technology, strategic partnerships, and short and long-term technology roadmaps for high-tech products. Lou's current focus on Dassault Systems includes global management of high-tech solutions within the Dassault Systems portfolio. Assuming we have time at the end, we will field some questions in a formal Q&A. And thank you for your attention. Now over to you, Ed and Lou.
Thanks, Brianna. Thank you very much. We've got together 75 years of experience doing system engineering, everything from PCB design to full systems engineering, testing, simulation, and then working with the software groups. Lou worked with the Solidworks and mechanical guys over the years, and advanced simulation. The high tech is in engineering, the complexity, the model-based engineering and system engineering, systems of systems, making sure that you have all your I's dotted and your T's crossed when it comes to all these different disparate processes. You really need to have your finger on the control and be able to create these digital twins and do this simulation virtually instead of in the lab. You could be there simulating and changing one variable at a time. And with that said, there's a whole process when it comes to product development, engineering, multidiscipline, governance, product requirements. I mean, who sets the product requirements? Well, typically marketing, sales. It could be a product requirement from the government that says, okay, you have to have this box. It has to do that. It has to fit on this airframe. It could be a commercial design, industrial concept, intellectual property that you're putting into a chip and creating a new product. Basically, creating something new like this. This is a concept product that Dassault came up with. This BB. It's really just a cool Bluetooth speaker that kind of sits up by itself, and it integrates the full plethora of mechanical system, software, advanced packaging, because some of these packages and printed circuit boards may be curved or rounded, and then following that all the way in through manufacturing and making sure that this is producible, being able to control the manufacturing machines, the industrial equipment, and with being able to produce this, whether it's onshore or offshore. That ability to collaborate with those guys is really, really super important. This is kind of a view, if you will, of kind of the disparate processes and software that are out there today. I mean, this is just real life. You've got Microsoft Office, you've got SolidWorks for CAD. You might have Cadence, you might have Altium Mentor. There's any one of those ECAD systems there. And how do you keep manage the projects? Use Jira. We use Slack at one of the companies that I work for. So just an interesting view of this. And working for 20 years with Cadence, I can say I saw this over and over and over again. I also worked at Mentor for 6 years as well. So same thing, right, Lou?
Very well articulated, Ed. Well, this is what we typically see at our customers. This is kind of a real interesting snapshot when you see all these disparate systems. It's when we talk to the IT department and the IT heads, they just shake their heads and just say, is there a better way? And that's kind of where we're going to introduce the 3D experience platform to kind of consolidate all of this stuff without losing it. I mean, a lot of companies have invested a lot of money in these platforms and these products, and over time they need to improve. And so what we've created the ability, through the 3D experience platform, which is really truly a platform that allows you to kind of use your existing products today and then migrate over time as the company matures and grows into the 3D experience tool. So, in the beginning you can reuse a lot of your assets and continue to go, but we see a lot of companies moving into this space because it's just the total cost of ownership, and the 3D experience platform is a cloud platform. So the overall total cost of ownership is much less to do that, and there's no overhead per se. Your IT department has other things to worry about, and most of the products out there today can be used on the 3D experience platform with our included tools. And then connecting to other systems like ERP systems is a necessity. ERP and MRP systems is always going on there. And the latest thing that we're seeing a lot of is companies connecting to single source of sign-on or single source of security systems. So we've seen a lot of integration with other types such as Okta and Ping for doing this type of stuff. So the nice thing about the 3D experience platform, it's designed for this. It's designed as a platform to interact with not just CAD tools and ECAD and MCAD and software development tools, but to work with your business tools. So it becomes more of a platform approach. So it's really, it's a single source of truth of all your data being placed in one cloud solution. And it can be cloud on-premise, or it can actually be private hosted, depending on what the customer needs.
Yeah, one of the things that you also mentioned to me the other day, Lou, was when you had all those disparate processes and systems, when you have a merger or acquisition, this is really a way to work together on a project. Let's say you have a helicopter or Osprey or F-35, God forbid, and you've got all these subcontractors and vendors and people using different stuff. They're actually able to work on a product or a project together, right?
Well, one of the great starting points of the platform is the ability to take all that data and show it out as a dashboard. I mean, really, it's a great starting point where you have all these disparate systems. And imagine being able to get all your information in one place, and it doesn't matter if it's ECAD, MCAD, your Word documents, your Office documents, if you're connecting to other systems, other types of data sources, other simulation, and then also being able to look at requirements, things that you need to do, your tasks, deliverables, all in one dashboard. And think about it from a management perspective, but a product management perspective, it simplifies that job of collecting all the data from all the disparate systems and kind of putting it all together in a dashboard. And all these tools can be put together using what we call simple widgets on the dashboard, and to create a holistic view of your project.
Yeah, those are the really cool things that I thought when I first saw the dashboards, Lou, was, hey, I can launch, I can see my different tasks. If there's an ECO process that happens, I get a notice on the dashboard saying, hey, with the milestones in the project. So you see all this stuff in one place, and not only can you see it, but program management can see it. Everybody knows where everybody else is, and like you said, it's on the cloud, so it's right there.
It makes it right there. So let's take a look at the accelerated device, and it's pretty straightforward. The last webinar we did together, Ed, we talked about governance, and so when you really look at the 3D experience platform, it really an accelerated device, we really bring it down into multiple segments. And today, we're really going to talk about design and engineering, the real meat and potatoes of what we can do with the platform. And this is kind of talking about multi-CAD and looking at different aspects of the platform per se itself. And like I said, last time we really talked about governance, but this time let's just dig in, and we'll dig in and talk about design and engineering tools and capabilities of taking a platform approach. And hopefully you'll join us for another series of webinars where we're going to talk about the manufacturing, because it's great to have products, to design them and to be able to support them, but the next thing is you have to make sure that they're manufacturable and you can actually manufacture them. So so that would be our next webinar we do, Ed.
Yeah, no, that's exciting. The manufacturing link to that, Lou, and the other thing that's really cool is that, not only are they segmented that way, but, if there's a specific industry, Dassault and EMA really focus on specific industries. So there's a solution, there's product dashboards that are basically put together for specific industries. So you can kind of think of that as a stay on task with what is that you're doing for that specific industry.
Look at the 3D experience as more of a very strategic way of doing things, because it's a very holistic view. We're not looking at individual tools. We call them authoring tools. So it's really, authoring tools, and then how do you use those authoring tools data over and over again? And that's kind of what we're looking at. It's really a holistic view. Yeah,
and it's nice that it's it's ECAD, design authoring tools agnostic, or even MCAD agnostic too, right, Lou? Because you've got Creo, you've got Solidworks, you got whatever.
As we go through through this webinar, we'll show you some of the tools. We're going to show you some of the in-depth design tools and some of the tools that cross over into from other suppliers.
Yeah, I'm glad you mentioned that, Lou.
The whole thing here is that it's a unified platform, and we're looking at a platform approach, and we're taking a model-based engineering approach to the design.
Yep. Yeah, the model-based engineering, being able to do, block diagram editing and work at that level, with data-driven, and the tools being native inside of the platform, looking at real data inside the platform. It's not an interface, but we have interfaces, and they work great with all these different tools, right?
Oh, absolutely. So how we look at it is we're connecting the present to the future. We think that model-based engineering and model-based systems engineering are really the next generation when we talk about cyber-physical systems, and as we get into more complex engineering tools. So the days of thinking with blinders on are pretty much gone for a lot of engineers, where the electrical guys have to make sure that their requirements meet the mechanical guys. The mechanical guys have to meet the requirements of the electrical guys. And let's not forget, all this stuff nowadays runs on software, so all the software has to be cohesive. So having a platform approach really allows us to manage all of the data properly, support change management and change action, and really drive the manufacturing side. And let's not forget the old measure twice, count once mentality that everybody wants to use, is where we do a lot of simulation. Can you imagine doing a multi-industry, multi-tool simulation and finding out the best parameters that you need to do? So we can do a lot of that type of technology.
Yeah, it's creating that. I always look back at the crash dummies. It's if we had the ability back in the day to create the digital twin of that, we could run the simulation, and it's like that. Whether it's structural, whether it's electrical, mechanical, computational fluid dynamics. Once that data is on the platform, you can simulate away, right, Lou? I mean, you can simulate, a battleship, create a digital twin of a battleship.
We have aircraft carriers, battleships, and being Dassault, we're in many industries, and I've been into what we call our digital or augmented reality cave. And the next thing they tell you to close your eyes. When you open your eyes, I'm on the end of the runway, standing on a bar at the end of an aircraft carrier, swaying in the ocean with an aircraft ready to take off. So you can do unbelievable type technology if you need to.
Yeah, and really combine those different simulations, together. One might be CFD and thermal transfer. Another one might be structural, and another one might be electromagnetic. It's all in there.
Oh yeah. And how does it all interplay with both your electronics and your mechanical? How do you know what's the best trade-off to make? Do you raise the ocean or do you lower the ocean? So really, having this type of tools that allow you to do the what if on multiple discipline is incredible these days.
Yeah, that's a great point that you bring up, Lou. Is since you have this all integrated, from a mechanical standpoint, if you can't cure the electromagnetic issues, maybe you redesign the enclosure to hide some of those, or use the Faraday cage to keep that inside instead of outside.
So let's move on here, and let's talk about my favorite topic is taste great, less filling type topic. It's really the advanced mechanical and electrical collaboration. So let's take a look at here. And for this example, I'm going to walk through the day in the life of a product being upgraded, and I'm going to talk about it from the top level, where the product manager is going to actually launch this change order, and we're going to walk through on how the 3D experience works. And for the first part of this, I'm going to talk about it. We're going to show you the cadence connector that allows us to show cadence. And then in the second part, we're going to talk a little bit about component libraries, very, very important. And we're going to show you multiple products as we walk along, because most companies have multiple ECAD, multiple NCAD products. So the first solution I'm going to show you here is the 3D experience working with cadence. And then the next piece, when I talk about libraries, will be the same exact scenario, but I'll be working with Altium data right here. So now we're going to talk with Evan. Evan's a quintessential project manager. And Evan realizes that, through some information, that they need to change one of the printed circuit boards inside of one of the systems. So very easily they needed to change it. So Evan creates a change order, sends some notes over. He says that this printed circuit board that's sitting within the system on top of the 3D experience, he sends a change action to Sarah, our cadence design engineer, and it's telling her that the change that she needs a change to take place in the design. So think about it. We're taking a very high level look at this here. She's notified of the change. She goes to the 3D experience platform, which is highly integrated into the cadence design system. She opens up the project, and then from when she opens up the project, she can bring the project into cadence, and she'll be looking at the project, and she'll say, oh, she'll look at the requirements, and now she'll say load the particular job. So she's going to load the job for that particular machine, and she says, oh, look, there's a change order against that from the project manager. So she reads through the project changes. She looks at the printed circuit board. So she's going to look at the work. So what she's going to do is she's going to open up the design. She's going to update the schematic and make the changes. And when she makes the changes, she will save it back into the 3D experience platform. But when she makes the changes back into the 3D experience platform, it's checking to make sure that the design meets the design intent, and also that all of the parts have been released. So you see here that she's putting the parts, and she's trying to see if the parts have been released. She's looking at the changes, and then she's going to release the product, and she's going to change the process, and she's going to reset the product life cycle of the product, and she's going to release the parts. Well, the things that the system does is it makes sure that all of the parts that Sarah had put into the product have meeting the requirements and have been through workflow and such. So now she's released the product. She's bringing it back up for the stakeholders to take a look at, and you'll see as we walk through, you'll see that now we see an element that says that it's a Cadence Allegro design element, and basically you'll see a virtual image of the printed circuit board on the 3D experience platform. She does a change action to release it. It walks through workflow, and then it gets automatically replaced into the top level assembly. So really, it allows full immersion of the Allegro product, easy search and access to open the design projects from the 3D experience, automatic generation of tailored manufacturing outputs. It will automatically generate all of your Gerbers and such and place them into the archives, and it'll also change all of the notations on the documents and save them to the platform for distribution to your supply chain. And it can actually notify your supply chain that you've made changes, and complete control through all of the different uses of this. And now, again, this works with almost all brands of ECAD solutions. So in this particular side, I showed you how easy it is to collaborate, to store your files, bring them back down, and to make a change at a project level. Now let's take a look at this thing. Now let's take a look at the libraries. We're going to use Altium for the libraries so that we can show that we're multidiscipline based. So here you're going to see we're going to bring up the Allegro component editor, and from the component editor you're going to see the components are created. It brings up a template for us, and within this template we have all of the components. We have the schematic footprint, the 3D element. We have all of the design features and elements that are necessary to do that, and we also have all of the 3D parameters and all of the parameters. So the 3D experience platform, because we're simulation based, here you can see it here, we're simulation based, we can also put in simulation parameters, and we put in the values of the components. So this is a holistic place to put in all of your part information that's going to be used in using your design. You'll put in, like I said, you can put in the schematic. It'll automatically create a 3D package. You can reuse your existing libraries that you have You can cross libraries with, between different packages, so that you have one footprint, one set unique capability. The thing that's really unique about the system is it allows you to have one product structure with all of your design elements, no matter if it's mechanical, physical, or software, and anything beyond. So it's really unique capabilities of maintaining all of your libraries and such. And we also have capabilities to do the next generation, where we can actually manage obsolescence, ROHS, and reach. We also have those type of capabilities in the system. So here I'm going to hand this over to Ed, and this is where we start talking about real physical design. So you've created your design, and now we really want to take a look at this. And now it's really the collaboration between the ECAD and the MCAD. And in the scenarios here, we're going to be using two different ways. If you use the interfaces that I just showed you, we can take it directly from the platform. And then we also can maintain, depending on what ECAD package you have, the ability to read IDF ProStep data. And so I'll have Ed walk you through that.
Sure. Thanks, Lou. The thing that I thought was really cool about the couple of videos too, I'm a ECAD guy for many years, and all those changes, that ECO process, maintaining the versions and control of that is, in the first video, it was all done inside of Cadence. So you could see from the project manager, you were actually going in and launching and checking out the dashboard from the actual Cadence tool. So they're integrated into that process, and the same goes with the second video in Altium. It was fantastic. On the platform itself, those connectors are absolutely spot on. And having done printed circuit board design and system design, both of us for decades, I guess we could safely say, Lou, there's these great interfaces that we have, IDF, IDX, IPC 2581. There's a whole bunch of different standards that are out there, and allows a smooth transition of enclosure boards and really the handoff, and creating baselines. There's a whole bunch of different things. If you guys have questions, this process has been vetted inside out with a number of different vendors. Like I said, pretty much everybody in every industry is doing some type of multiple printed circuit boards, or maybe even stacking ICs on top of each other. Depends on how small and how dense you want to become. In fact, I think Lou was telling me the other day about a client that actually molded the interconnect into plastics or something for an automotive.
Oh, we have some advanced tech that we could show in another webinar that's unbelievable. It's we call it it's the next generation of electronics, and it's not really that next generation. All the automotive guys are doing it now, and it's not traditional MEP or MES technologies. It's really the next gen, where we're taking the printed circuit board information and we're deforming it, and at the 2D level, deforming it, and then being able to make a 3D mold of it, and actually vacuum forming electronics and stuff. And we can show that maybe in a future webinar. That's just unbelievable tech.
Absolutely. Smaller, faster, more technology encompassing smarter, smarter technology. You can make it smarter because you can make it smaller and do all these different things. So one of these things is, it just says smartwatch, but I actually have a Garmin watch, which I absolutely love. You've got GPS, you've got, barometric pressure, you've got all types of different capabilities inside of this. In this video, it is kind of interesting because it's going to show how we can package, create the flexible circuits that are associated with that connect to the rigid circuit boards, and whether they're in a box that goes on an airplane or into a watch. It's as easy as selecting the parameters, taking that information from the ECAD as IDF, transferring it over, setting up a baseline, and then defining what comes over, whether parts come over, etch. Any variety of communication between the ECAD and MCAD process. So, it's very easy to run what if scenarios on, what if I bend it this way? How does that affect my Bluetooth, for instance? How is that going to communicate with my headphones or whatever? And now, how do I actually connect these boards together? Do I use a connector? No, connectors are big and bulky. I want to use a flex circuit. Or rigid flex circuit, and I select one edge of the board, the other edge of the board, and I can even look at the stack ups in between and say, okay, these connections are on this layer and that layer, and then define how I want those things to be, whether I want it to be minimum distance, but I might have to do some. Well, there's an issue. there's interference. So I can set inside of CATIA, I can set the the parameters such that, okay, I can have a big bulky one like that, or I can say, hey, use that interference that I'm having as a base and just avoid that. So there's a avoidance in there. There's checking, and when you go back and forth on either side, there's checking everywhere. And this is of course how you'd want to see it, for a manufacturing process where it's unfolded, and then back into the actual watch itself. But we vetted this process, whether it's for smartwatches, iPhones, or any other type of consumer product that's out there today.
I call it my origami product.
Yeah, exactly, Lou. If you have a tablet PC or a Chromebook, or you gotta pack all this stuff in there because you need a hard drive, you need some way to get the graphics out. You've got all these interfaces and other things. You've got a power circuit. All these things come over, and being able to take and parameterize and create constraint areas and be able to check for these interferences like we had in the smartwatch section. It's the same thing on a laptop or a notebook or anything else. You want to have that obstacle avoidance, and having a robust ECAD system that can pass that information back and forth is critically important.
And then if you harness the power of the platform, you can actually figure out how many times you can unfold and unfold it before you do damage. That type of stuff is just amazing technology that's used. And you ever want to take apart something, or anybody you ever want to take apart anything, is try to take apart a camera. They are just amazing electronics packed into a camera. It just, every time I open one up, or every time I see a design from a camera manufacturer, I am just in awe of how they take this technology to the next level.
Certainly, you're going to have the same kind of, and this is exactly what they did. It's like, okay, somebody wants a small thing. It's like, fitting it into your Android or Apple-based phone. You want it to be a certain size. You want it to be a certain quality, and all that's got to fit into an enclosure. And being able to do, like you said, the what ifs that are associated with that, in creating those constraint areas, like you'll see in this example here. It's the same kind of idea. This is a CATIA version of that, where you want to have keep outs, or certain components can't be over a certain height in different areas, or can't be there at all. This information is communicated back and forth with IDF, in any standard tool, EDA tool, to the mechanical tool. This is kind of the next level when it comes to being able to integrate the etch, the vias, components, different assemblies, different enclosures, even, the red areas where of course the components were too high, so we'd have to do some modification there. And here's the flex circuit that we forgot about and needed to put in at the last moment. So it goes from the connector here, and there'll be a little, in fact, maybe this is even the camera. Yeah, this is the camera portion that, there's a part that was, where we wanted to have the camera, and we couldn't move it around because of the proximity that it needed to be with the other IC. So, we cut a little bit out of the flexible Kapton that's associated with the flex circuit, and said, okay, hey, let's move our camera up a bit. It's small enough where we'll fit in this, and do the what ifs. And that was an important thing that you mentioned, Lou, is this capability is going to allow you to do more what ifs. What if I move this here? What if I put it on the other side of the board, giving you the capability of seeing if this is going to fit, seeing if this will work, be more optimum.
Well, it comes out that no good electrical product doesn't have a package. So we've kind of showed you how we can handle rigid boards, rigid stack-up boards. Traditional software, non-platform based type software can handle a single card entity back and forth. Now it gets more complicated, as Ed showed you, when we're doing the origami designs, where we have maybe a single printed circuit board that's folded up, or we have the rigid that has multiple pieces, multiple printed circuit boards, and then on top of it has mechanical features, such as, like in that particular case, it had disk drives and cameras and had to fit in a housing. Well, nothing would be great, and so, but But one of the things that's real important is you need to build the housing. And because of, being from the SolidWorks CATIA world, we're going to show you some technology that's going to really make building housings much easier. We have a product, and we're going to kind of walk through a video on it. And it's called Product Closure Engineer. What it allows you to do is to do to really define the engineering, that you're going to do on your mechanical, and have it work very, very succinctly with your electronics design. And it's also going to allow you to reuse features and technology that you currently use, because you need to keep consistency, we found, in the manufacturing. So we have a particular type of IP or a typical type of way you do things with ribs or bosses and stuff like that. We can, there's templates available in here, and allows you to do different types of technology, because really at the end of the day, you need to be able to, to produce and to actually plastic mold. Now here, we're kind of take the printed circuit board, bring it into that plastic frame, and then from here, we're going to be able to actually do measure ups and to make sure that there's no collisions and that everything can kind of go back together. Because if you do make a change, you don't want to have those collisions and stuff. So as you're designing your printed circuit board, if you need to do an outline change, or you actually change a component, you'll never know what the height or what the parameters are that you may have. You've moved a part too close to something. So we can actually, bring that back in again and take a look at it at the assembly level, really understand what your impact of your changes. And then these tools are great, because you can't produce product unless a real product. It really takes, electronics, mechanical, and software. So right now, we're talking about the mechanical side. Basically, what we want to talk about is the integration of with SolidWorks. I mean, a lot of companies that use Cadence products also use SolidWorks or a third party, and I'll show you some third party ones. But the platform is great, because it allows us to integrate into the platform, no matter whose mechanical CAD you're using or whose electrical CAD you're using. So let's move to the video here. And this video is very interesting. Is what I'm going to show you, and I'll just kind of walk you through, is going to be very straightforward. And what we're going to see here is any activity from starts with a change process. Something needs to be fixed or something needs to be done. So here, what we found out is that the battery it needs to be changed in size. So it's very easy. They're going to add some more cells. So the SolidWorks engineer goes in and changes the battery in this product. Well, this product is made up of multiple users and multiple pieces. So the frame of this particular product, or this is again, it's beamy, was designed in CATIA. So now we need to put that new battery in there. So basically, the change management knew that we made a change into a mechanical item that's going to impact the mechanical design. So it sends a change notification in here. And really, what this tool allows you to do is, we call it mastering the design complexity, is it allows us to really go into a design and integrate the true mechatronic solution, where we can integrate both mechanical and electrical systems. You can see that we're going to be doing different pin designs, for snap-in features. And then the thing that's interesting is we can actually put the printed circuit board in there. And what's really, really interesting is we can look at different variants. So if we need to make different variants of it so that we can make sure everything fits together nicely, is we can do different variants. Again, we can do electronic board fit up, and then the other technology as necessary into the product. So what we have is the ability to look at different technologies that you want to use, and then we're going to show you some what we call regenerative engineering, where and here we're seeing simulation, what if scenarios, we talked about that, and then regenerative engineering, where we need to make something quicker, lighter, and we set the parameters and we let the software do it. And then what you're seeing is mold setup and mechatronics with kinematics. This is all running on the platform based on these designs that are coming in and coming into the product. And really, so what you can see is we can do topology optimization and then refinement. And these are really tools that are done in the mechanical side, but again, they interact with the electronics. So when we look at things as product as a product, and it includes electronics, mechanical, and software. Here we're walking through the mechanisms to do change. We're doing a change management to the frame, and we're going to change the status of it, and we're going to release the product, and we put it into a release state. So we can do that for all of the different items and different processes going through. So we have full control and full traceability of the status of every design item and everything that you're doing, including, so it gives you a single source of truth. Now I'm going to show you something, because not all CAD companies use Dassault products. So here we're going to launch it. Now you're seeing the product, and this is a combination of different products. So it's got ECAD, MCAD, and software in it. And so again, we're going to launch this product. and we're going to run it through. It's on the 3D Experience platform. It's all put together. The assembly's put together, and we're walking through it. And now what you're seeing is we're looking through at it and say, I need to make a change to this back plate. Well, the back plate happened to be designed in Creo. So what we do is at the product, you'll see that the 3D Experience will launch Creo, allow you to bring the product into Creo, make the appropriate changes. Now here we're going to make a change saying, we don't have enough air, we need to change the airflow in the system. So our simulation said we need to make some changes. So we're making changes in the airflow. We're using the native design tool, or what we call the authoring tool. We're going to make the changes inside of the authoring tool. And then once we're done, we're going to save it back to the platform, and it's going to go back and it's going to be put back in place, so that basically what we're showing here is the ability to take multi-CAD from multiple vendors and being able to use them in your final product assembly and to author them as necessary. We don't author the particular multi-CAD product inside the platform, but you'll see that it updates this, it updates the bill of materials, it updates all of the information and reference documents and puts it back in place and re-renders it so we can see the new changes that we've done. This is really the power of a platform. We're not dependent on any particular MCAD user. This is really, and we can do this with most MCAD systems and most ECAD systems. So it's really very powerful when you're in an environment where we have multi-CAD and multi-users, and it's invaluable when you're doing smart product design, because you'll find that not every tool will work, or you have tools that you want to cross working within the company.
And you're working together, you're collaborating, maybe even doing it concurrently. So, you're doing things at the same time, and you're doing things together, and the platform enables that process, not only from a mechanical, but now you're including, the hooks to manufacturing, and as we're going to show in a second, the software part of the process as well.
What we found and we kind of outlined this on the last webinar we did, is that with the unfortunate circumstances of the pandemic, the platform has been invaluable, because today people can stay at their homes and work like they're in their office, because of the way the technology is that it's cloud-based and basically highly secure, and you can be working together on products no matter where you are in the globe. This is not a site design product unless you happen to be, needing to have it on premise for security reasons. But it's been invaluable to companies. And just think about if you're working on mechatronics or these high-tech, smart devices. You may be working with multiple design people. You may be working on somebody doing your RF simulation. You may be working on somebody doing all of your different pieces. Using the platform approach allows multiple distributed engineering to take place. It's unbelievable how powerful it is. Now I'm going to talk about my favorite subject in all time is software. Everything in the world today has software. And then it has multiple layers of software. We have software inside the cloud. We have software we have inside the product, we may call it firmware. And then we have applications that run on top of this. And then we have things that you call paid applications and things. So when you look at building a smart product, how do you know how it's shipped? How do you know what is the snapshot? It's hard enough today when you're building mechanical and electrical, when you marry them together, know what the bill of material is. Now that you have software configured products where your hardware and your mechanical have been kind of united, how do you handle that? So we'll walk through it real quick, but I'm just going to show you is that we handle it the same way we handle the ECAD and the MCAD. Is that basically we can connect to your repositories, and we can actually take a snapshot. And one of the things that we do that's very different is that we typically connect to a product, and we connect through either most GitHub or Git library. We also see a few other technologies. One of the things that we've learned with working with software people is that they have iterations that they do, and they like to use their own products. They like to have their own little nest of how they build the product daily, and how they're doing their designs daily, and how they're doing their check-ins, check-outs using the tools that they use. But those tools never align typically to the processes for the electrical and mechanical. What you're seeing here is the ability to look at all of the repository information, no matter if it's the source code, the compiled code, all of the runtime, the libraries, even the compilers can all be, or when you branch, you can take a snapshot, put that into the 3D Experience platform, take a look at it. You'll have a complete overview of how you built that product and what it is at that time of release that's connected to your mechanical and electrical build at the exact same time. So what we do is we kind of sit on top of the repositories or the way the software guys do, but we align it to the product when it's being released. And at any given time, if you want to, you can actually take different snapshots of the product, of the software. We found that that's the way most people operate, is that the software engineers do their thing, they run around and they get things done. And then as we get more complicated and more sophisticated in our designs, is that we'll see is that we can actually drive software through requirements management and really see the progression of software. So it's not just a matter of taking a look and getting a snapshot of the picture and building a bill of material item. We can actually start triggering events to take place. But you'll find that today in smart products, software is unbelievably complex to herd the cats, is the best way to put it, because you have so many different departments now. But at the end of the day, when you're shipping a product or you're producing a product, you need to know the mechanical vintage, the electronics vintage, and the software components and vintage and where and how they were produced. And that's what the 3D Experience platform allows you to bring to the table. And we can also capture simulation information. So we, I mentioned before, measure once, cut twice. We're not spending a whole lot of time on it in this webinar because I really wanted to show you that the 3D Experience platform can support your mechanical and your electrical and your origami designs and all sorts of technology. But one of the things that we do bring to the table is the ability to do all sorts of simulation and technology, both mechanical and electronics simulation, depending on what your needs are. And so, that may be a future webinar that we do on the technology, but we can do structural analysis, we can do packaging. One of the things that we do a lot of things is packaging analysis. You build these great products and you've put them together, you've got them bolted, you got the mechanical, you got everything under control, you put them in a box and you put them on a truck or a container and they drop. How do you know that your box is going to perform? We have simulation software that can produce, drop testing and such. So, that's part of the 3D Experience platform. But if there's any questions, feel free to put them up on there.
Yeah, between the software and I don't know if anybody noticed, but as we went through there were these workflows or these process steps that would pop up, and the platform allows you to not only have the dashboard, but inside that dashboard you can customize the workflows or the process flows, if you will, and you can set steps or set requirements at certain points in the process. If you had a critical design review or preliminary design review and people needed to be called in, they get a notification on their dashboard and on site or remotely, and be able to keep abreast of where the actual project is. And management can have that view and not be kind of looking over your shoulder all the time. They're gonna see that real time as it's being developed, and as it goes into manufacturing. Because the interesting thing is, Lou, you and I have designed all kinds of systems over the years, and a lot of times it was like, okay, throw it over the wall, let them figure out how to build it. It's functionally and it works, but that's not really the case.
Yeah, our next topic we'll really talk about and will be the digital twin. And that's really, really important because when you talk about manufacturing, you really need to produce it. So what we've shown you is the ability to take your electronics, bring them into the platform, visualize them, maintain all of your libraries, and maintaining and doing the exact same thing for your mechanical side and then doing the same thing for your software. So we're providing a platform that can do all that capability. And then it doesn't matter, we're vendor agnostic. And then on top of that, we can run simulation capabilities on top of that in these multi-systems and do trade-off analyses. The thing that's great about the 3D Experience platform, it's modular, and then you can start with what you need, and as your business grows, you can grow with the platform. So it really provides a lot of capability. And so, one of the things that we talk about is this accelerated device, and really one of the most important things that we address with most customers right out of the box is the as-built bill of materials. And you've kind of heard me stress that a lot because it really resonates with a lot of customers when things are going out the door or going into manufacturing. What are they really building? And what is the impact of a change order or an ECO or an ECN? What does it really do to your system? And we can really do all that and really help in a collaborative way.
Great point, Lou. The other thing that that we touched upon, but the online supplier and manufacturing collaboration. So manufacturing can be in their dashboard looking at information real time and posting feedback or asking to maybe change the wave soldering machine would be more efficient. You wouldn't get tombstoning if you align these components a certain direction. So there'd be real-time feedback with manufacturing, and it could be product suppliers as well.
Come to our next webinar on manufacturing. It's fascinating of looking at this. As Ed's talking about this taking a look at the defect management and looking at how you can use a digital twin to figure out what is going to be causing the defects, and literally how do you set up your factory? What is the impact of putting on that new type of VGA on your factory? What is the impact going to be on your production line? That type of stuff can be done in the digital twin. So when we talk about accelerated device, most of our customers it allows them to do more design iterations. So they do about 30% more iterations. It sounds like more work, but it's all within the same time window because of the ability to be flexible. You can make a lot of changes, and you also become about 40% more efficient. And then what we're finding is it's really important is downstream in manufacturing. We're finding about up to 60% on average time saving on the assembly processes that take place when we go through these digital methodologies and really using the tools to build smart products.
Game changing, Lou. Like you said, you're able to do multiple iterations, multiple what ifs, and maybe it's a product variation too. So you have these variants. Okay, this product does that. What happens if I add Bluetooth to this product, or I add some other type of interface? It allows you to be more competitive and add things that other people don't and be more competitive in the market.
And we can really talk about what our goal at Dassault Systems is very straightforward, is to merge the virtual and the real. We would like them to be able to do everything in virtual and create and have it reflect the real, so that basically our goal is to bring them as close as we can together, so that at the end of the day, what you design or 100% represent what you're putting into the factories and such, because that's at the end of the day what people want.
Yep, thank you, Ed. If you have any questions, please insert them into the questions panel.
There's a great question that just came in that I just saw, and it's from one of the questions. And the question, does the platform help support integrity software? We have some members of the team that do finite element analysis. It would be great if the board designers and mechanical designers can make updates to help their integrity engineers analyze and update issues like vibration models, and et cetera. The 3D Experience platform can integrate, especially with software, especially on the simulation side. We have an entire brand called Simula that has all sorts of tools that would be able to integrate into this. And the 3D Experience platform is really tuned to work with all of these tools. And you can see here, we can do airflow, we can do vibration, we can do EMI, RFI. We do a lot of advanced. We do advanced CFD. We do all sorts of stuff, lightning strike. You can imagine, if you can imagine that we can do it. We have, I'd say, one of the most comprehensive suites of simulation products out there, in both mechanical and I would say in some of the electrical stuff. But then we are complementary to other tools from partner companies like Cadence that we work with. So there are lots of tools out there. And the thing that's interesting is we can take a lot of these results and do what if analysis, because if you strengthen something, you may break something else. Or if you're doing EMI and you're jamming, you put an antenna somewhere and you're jamming. So when I move the antenna, what does that do? Does that increase the radiation pattern? Does it jam inside the product? So simulation is part of the notation of the engineering side of the platform. Like again here, what we were trying to do is really talk about, in this particular webinar, was really talk about the electromechanical and software side of it, but there's an entire side of simulation that's part of the platform. We get into batteries right down to the chemistry if we need be.
Yeah, acoustic waves, all kinds of other capabilities too. I mean, it's really mind-boggling when you look at the capability, all of the different capabilities of high tech and Simula. It's pretty.
Yeah, when you talk about it's just a product called Sonic Wave, and it's really cool. Is think about when you're building a helicopter and trying to land that in next to a glass building. What are you going to do to the building? So some of these new autonomous vehicles they're talking about, even a drone, what do you do? What happens when you break the sound barrier? So we're looking at all sorts of cool technology of how do you dampen that? How do you do that? And same with batteries. We go into chemistry of batteries if we need to. How do you get the extra mile out of it?
Paulo, we are reaching the end of our time here. So I'd like to wrap up. And if there are any other questions that anyone may have after the webinar, you can always reach out to us, and we'll be happy to get in contact with you. And as we wrap up today, I'd like to remind you also that there will be another webinar in this series involving manufacturing. So keep an eye out for that information. And thank you all for taking your time to join us today. And thank you, Ed and Lou.
Absolutely. Thank you, Brianna. Thank you, Lou. And I think if they want the first webinar that we did too, we've got links to that as well.
And more importantly, please let us know how we can help you. You know, we're here to support you guys. So let us know how Dassault and EMA can help support your company.
Absolutely. We've been doing this a long time, and you know, we really enjoy working with folks to be successful. That's really what matters to us. Thank you all.
Alrighty.
Thanks, Lou.
Bye.
Bye-bye.